After learning how to find the area of a parallelogram, it's important to be able to find the area of a triangle. And finding the area of a triangle is a lot easier after you realize how to find the area of a parallelogram. Okay? And it's because when we look at a triangle, we need to realize that it is half of a rectangle. So I have a triangle here, and if I drew imaginary lines, which I'm representing with the dots, you can see that there is a rectangle here. Okay? I could have another triangle, slightly different shape, okay? But this one is still half of a rectangle, okay? If I took this piece here, I'll shade that in for you, this piece, and added it to this piece, it would be the same as my green triangle in the middle, okay? Both the triangle on the left here and the triangle on the right here are half of the larger rectangles. Okay? So, it's important to realize that because when we look at the formula to find a triangle, it takes the formula of a parallelogram and splits it. Okay? So what does that mean? To find the area, remember represented by A, of a triangle, and I drew a little triangle here, doesn't really look like one, but it is one, we find the base times height divided by 2, okay, which is the same as the area of a triangle being equal to 1/2 base times height, okay? Multiplying it by 1/2 and dividing it by 2 is the same thing, okay? If I have a triangle here, okay, the base is the bottom, and the height is how high it goes up, okay? That might be represented a little bit differently, okay? If I have a triangle that is, well, slightly different shape, okay? So say that I have a triangle like this, okay? What will frequently happen if you're not being asked to measure it is there might be a line, a dotted line, coming down from the middle, okay? That means that this line doesn't really exist as part of the shape, but it's there to represent that, yes, there is the height, okay, and the base is still here. This is still my base. Okay, and it's important to recognize both of those formats. Okay, so remember, base times height, which is my parallelogram formula, or rectangle, divided by 2, or 1/2 base times height. I like 1/2 base times height because it makes it a little bit easier to solve problems if you're given the area and the base or the height and the other is missing. So, but that's one of the more challenging problems. You want to make sure that you have the basic understanding of how to find the area of a rectangle first. Okay, so let's look at this triangle. First thing I'm going to do is write my formula. Area equals, and we'll do 1/2 times the base times the height. Okay, remember my base, in this case, is 3 meters, and my height is equal to 6 meters. Okay, copy the problem again. Area equals 1/2 times my base, which is 3 meters, times my height, which is 6 meters. Okay, and I'm going to copy it down for the next part. Area equals, and I'm going to do the 1/2 last because it's going to be easier if I do the other part first. 1/2 times 3 meters times 6 meters is 18 meters squared. Okay, just like we did it with the area of a parallelogram. Remember, it's like we're drawing imaginary squares, each a meter in length, inside the triangle. Okay, copy down the problem again. Area equals 1/2 times 18 meters squared, okay, which is the same as saying half of 18 meters squared, which is 9 meters squared. You want to make sure that you are keeping the meters squared. That is very important. Okay, 9 meters would be the length of a line or a line segment, not the length of, or not the area of it. Okay, we can also try it with 1/2, base times height divided by 2. Okay, let's try that here. Area equals base times height divided by 2. Remember, the base is equal to 3 meters, and the height is equal to 6 meters. Okay, copy the problem again. Area equals 3 meters times 6 meters divided by 2. Let's move that up so we can see it a little bit better. Area equals 3 times 6, which is 18, meters times meters, which is meters squared, divided by 2. Again, area is equal to 9 meters squared. And if we look at it, my solution here is the same as my solution up above. Okay? Same problem, slightly different formula to use, but it gets me to the same place. Let's try a different structure of a triangle. Okay? Remember, this line here does not actually exist. It's just saying that from this top point to the bottom is 5 feet. Okay? I cannot do the length of the hypotenuse here because then it's a different length than the actual height. And I haven't shown you how to do the hypotenuse. Okay? First step, write your area formula. Area. And you can do a triangle if you want. Ask your teacher or whoever is assessing it if you want it. When you get into multi-step problems, you're really going to want to do that. So I'm going to go ahead and include that here. Area of a triangle is equal to 1/2 times the base times the height. My base is equal to 8 feet. My height is equal to 5 feet. Okay, plug it into the problem. Area of a triangle is equal to 1/2 times 5 feet times 8 feet. Okay, next step, area of a triangle is equal to 1/2 times 5 times 8 is 40. Feet times feet is feet squared. Okay, area of a triangle is equal to 1/2 times 40, which is 20 feet squared. Okay, and I'll slide it up and we can do the other formula. Area of a triangle is equal to base times height divided by 2. Remember, the base is equal to 8 feet. The height is equal to 5 feet. Okay, come across. Area of a triangle is equal to 8 feet times 5 feet divided by 2. Bring it down. Area of a triangle equals 8 feet times 5 feet, which is 40 feet squared, divided by 2. Okay, area of a triangle is equal to 20 feet squared. And that is the same as what we had up above.